Hello, everyone. Today we are going to explore a mystery of Mars that has kept us all captivated. For decades, scientists have grappled with a persistent puzzle. Was Mars truly a frozen dead planet? Or did it once have liquid water capable of supporting life? We will look at how scientists have used a new approach to finally find an answer, the Great Martian Paradox. When discussing Mars, there is a problem that has long frustrated scientists. On one hand, data sent back by rovers like Curiosity and Perseverance provide solid geological evidence, such as ancient riverbeds and lake basins, proving that water once flowed on the surface. On the other hand, astronomical models suggest that ancient Mars should have been even colder than it is now because the sun's radiation was much weaker billions of years ago. This creates a massive contradiction. How could liquid lakes exist on a frozen planet? A recent study from Rice University has finally provided a theory to bridge this gap: the thin ice cover theory. The core of this theory is the thin ice cover. While we usually think of ice as something that freezes everything, ice actually has low thermal conductivity. This allows it to act like a blanket, trapping heat underneath and keeping the water below liquid. According to the scientific models, lakes in areas like the Gale crater near the Martian equator were covered by a thin layer of ice. During the winter, this ice acted as an insulator to prevent the water from freezing solid. In the summer, the ice allowed sunlight to pass through, creating a miniature greenhouse effect that warms the water beneath the surface. Why no signs of glacial erosion? The theory explains that this is because the ice cover was extremely thin and transient. Because the ice was so thin, it didn't have the mechanical power to grind down rocks or carve the landscape like Earth's massive glaciers. However, it was thick enough to protect the lake from dust and prevent the water from evaporating into the thin atmosphere. This is why we can still see perfectly preserved ancient shorelines and sedimentary layers in Gale crater today. A sanctuary for life. The fact that these sub-ice lakes could remain stable for decades, at least 50 to 100 years at a time, is biologically significant. Consider the subglacial lakes in Antarctica here on Earth. Despite the extreme cold, microbial life thrives beneath the ice. On Mars, while the surface was being bombarded by toxic radiation, these ice-covered lakes would have provided a perfect sanctuary, shielding potential life forms from radiation while providing a stable liquid environment. Three key factors supporting the theory. 1. The faint young sun. Ancient sunlight was about 30% dimmer than it is today. While it made it impossible for the whole planet to stay warm, the sub-ice warming method allowed localized liquid water to exist. 2. Martian axial tilt. When Mars' axial tilt, or obliquity, changed, more ice would accumulate near the equator, facilitating the formation of these specific types of lakes. And 3. Preventing evaporation. Because the Martian atmosphere is so thin, liquid water usually evaporates instantly. The ice layer acted as a lid, keeping the water trapped in the basin. This study teaches us an important lesson. A planet doesn't have to be warm and wet like Earth to host life. Even on frozen worlds, nature can create protective pockets where life can hide and survive. In the future, when humans eventually foot set on Mars or when more advanced robots begin deeper excavations, we might find ancient fossils buried beneath the soil of Gale crater. Mars is far more mysterious and perhaps was far more alive than we ever imagined. Thank you for joining us today. To keep exploring the wonders of space, don't forget to subscribe.